Well, we're ready for day 3 already, and time to get into resonance. Now, before we're going to start resonance today, start talking about it. Okay, we've got about 3 days worth of resonance to go over. But before we really get into resonance, we really need to understand standing waves, oscillations, things of that nature. Waves, actually, waves. We know that waves have a frequency. We know that waves have an amplitude. We know that waves has a period. Okay, the period is the wavelength, essentially, given is expressed in time, etc., etc. But the question what we don't really know is at this point, or some of you might, how do we create these waves? Okay, so we're going to start out with a few videos, all right, on showing you how a string vibrates. Okay, really everything really started with a vibrating string, because the solution to a vibrating string gives you an oscillating motion, an equation for oscillating. Basically, it's a sine wave. Okay, a sine wave is used to describe voltage and current in an AC signal. Okay, so when we speak of resonance and oscillations, that's what we're talking about. We're talking about waves that oscillate. Okay, they oscillate in a specific manner, usually in a sine manner, but it could be different. Okay, but the sine wave is the normal way of doing. Now, the electronics, we have sine waves for voltage and for current, and we have phase angles, etc., and so forth. But in electronics, we also have sine waves of different frequencies that are superimposed on each other. So what you get is a composite of many different frequency signals. Okay, and we use resonance and a few other things that we'll talk about next week to choose which we want to be able to select a specific frequency or a specific frequency range. Okay, so we're going to start off today very simply. Okay, we'll get a picture of what a wave looks like, and get a good picture of strings on a guitar, okay, with music that goes along with it. But then we'll get into a presentation for resonance starting today.